All right, everybody, welcome back. Get ready, because today we're going deep, like really deep.
Deep dive time.
Yeah, a deep dive into the world of digital images.
Oh, nice.
You know how much we all love our pictures, right? You've been digging into this stuff, right? I saw some of the stuff you were reading. It's serious computer science business we're talking about here. Pixels, color models, even how they shrink the files down.
Yeah.
Compression. Like, how do they even get those huge pictures onto our tiny phones? It's kind of crazy when you stop and think about it.
It really is. We just kind of take it for granted these days.
I know, right? Like, oh yeah, I just snapped this awesome sunset pic and boom, send it to everybody I know.
Exactly. Magic.
But it's not magic, is it? There's some real science happening behind the scenes. So let's break it down. We've got some fascinating sources here, and one of them starts off by saying that a digital image is, and I'm quoting here, formed by a series of programmed pixels. Okay, so I get that a pixel is like the teeny tiny building block of a picture. Like if you zoom way in, it's all these little squares.
Right, like a mosaic.
Exactly. But what's all this about them being programmed?
Well, each of those little pixels, right, they're not just blank squares. They can actually display color.
Okay.
And the color that each pixel shows, that's determined by, well, instructions, like code, It's telling the pixel how much red, green, and blue light to emit, like a tiny little light bulb.
RGB, I've heard of that. It's like mixing paint, but with light.
That's a great way to think about it.
Red, green, blue. Mix them together in the right way, and you get like a million different colors.
Pretty much, yeah. It's the foundation of how all these digital colors work.
So cool. But how does that connect to the pixels, though? Like, how do you go from these three primary colors to a full-blown picture with millions of pixels?
Think of it like those paint-by-number kits.
Oh, yeah. We get all those little numbered sections.
Right, and each number corresponds to a specific color.
Okay, I'm seeing where you're going with this.
So it's kind of similar with a digital image, except instead of numbers, you've got all these pixels laid out in a grid, and each pixel is assigned a specific color based on the instructions from the code. It's like the computer is the artist, carefully coloring in each tiny section to create the whole image.
So it's like the code is like a recipe for the image.
Exactly, like a super detailed recipe that tells each pixel exactly what color to be.
That's pretty amazing. But wait, aren't computers all about, like, ones and zeros, binary code and all that?
Yeah.
How do you go from ones and zeros to, like, I don't know, a picture of my dog?
That's where the CPU comes in, the central processing unit. It's like the brain of the computer.
Right.
And it's really good at crunching through all those ones and zeros.
Correct.
So every pixel's color, how bright it is, all that stuff. It's all determined by a sequence of bits, ones and zeros. And the CPU, it translates those bits into instructions that your screen can understand.
Wow, so every image I see is actually like a secret code.
In a way, yeah. It's like a language that the computer and the screen use to communicate.
My computer is speaking in code, and I had no idea.
Well, now you know the secret.
But all those instructions for every single pixel, that's got to take up a ton of space, right?
You would think so, wouldn't you? And that's where things get really clever. That's where image compression comes in.
Image compression. Okay, tell me more.
So, you know how we were talking about JPEGs earlier?
Yeah, those are like the most common type of image file, right?
Exactly. And they're a prime example of image compression. They use these fancy algorithms, these mathematical formulas, to shrink the file size way down without, hopefully, losing too much detail in the process.
Wait a minute, you're saying we're losing detail?
Well, not always. There are two types of compression, lossy and lossless.
Okay, this is getting complicated.
It's not as bad as it sounds. Lossy compression, like JPEGs, it's kind of like summarizing a book. You keep the main points, the important stuff, but you might leave out some of the smaller details, the descriptions and stuff.
So it's a trade-off,
Yeah.
right? Smaller file size, but maybe a little less detail?
Right. Then there's lossless compression, which is like making a perfect copy of the book. Every single word is the same. It preserves all the original data. But it usually doesn't shrink the file size quite as much.
So JPEGs, they're using lossy compression to make the file smaller.
Exactly. And most of the time, you don't even notice the missing details unless you zoom in really close, or you're printing a poster-sized image or something.
That makes sense. I mean, if every single picture on my phone was a massive file, I'd run out of storage space in, like, a day.
You'd be surprised how quickly those file sizes can add up.
Yeah.
Especially with the cameras on phones getting better and better.
I know, right? More megapixels, higher resolution. It's a good problem to have, I guess.
Yeah.
But it's crazy to think about how much is happening behind the scenes just to display a simple picture.
And we're just scratching the surface here. Think about all the other amazing things being done with digital images these days.
Like what?
Well, augmented reality, for one, where they overlay digital images onto the real world through your phone's camera.
Oh, yeah. Like those games where you catch Pokemon in your living room.
Exactly. And
Okay.
that's all built on these same fundamental concepts: pixels, color models, compression.
And AI generating images, right? Like those things where you type in the description and the AI just creates a brand new picture.
That's right. AI art and image generation are really exploding right now. And again, it all comes back to these basic principles of how digital images work.
It's like once you understand the foundation, you start seeing it everywhere.
Exactly. It's kind of mind-blowing when you think about it.
Seriously. Well, my mind is officially blown for today. Thanks for taking us on this incredible deep dive.
My pleasure. Always happy to talk about this stuff.
To everyone listening, keep exploring, keep learning. The world of digital images is vast and constantly evolving. Who knows what incredible things we'll be able to do with pictures in the future? Until next time, keep on snapping.
See ya!
Bye.